In this series of videos, we're going to be learning about radicals or refreshing our memory on working with radicals. In our first video here, we're going to rationalize denominators. So we've got the square root of 4/3. The square root of 4/3 is the same thing as the square root of 4 over the square root of 3. The square root of 4 becomes 2 over the square root of 3. Now, dividing by an irrational number by hand is not possible. So you can do it, but you can't do it accurately because that irrational number has decimals that keep going forever. So the square root of 3 is 1.7 something, 1.7, and it keeps going on and on and on forever. So if I divide 2 by a decimal that goes on forever, remember, when you divide by a decimal, you have to move your decimal place over however many decimals you have. And then you move that decimal place over and you bring it up to the top. Well, there would be nowhere to bring it up to the top because this decimal over here that we're dividing by goes on forever. So a way to get around this for mathematicians in the early days was to rationalize the denominator. So that's the whole purpose of rationalizing the denominator. Now we have all sorts of technology in which rationalizing the denominator isn't really helpful until you get to a class like calculus. But we do need that skill when we get to calculus, so we're going to practice it here. 2 divided by the square root of 3. Well, we're going to not actually do the division, but we are going to rationalize denominators. So when it says simplify, many math instructors, math teachers, still have rationalized the denominator in their thought process. So we're going to simplify the square root of 4/3. That's the square root of 4 over the square root of 3, which is 2 over the square root of 3, and then we have to rationalize. So we're going to rationalize by multiplying by a factor of 1. Multiplying by a factor of 1 changes what our expression looks like, but not its value. The reason why we're going to multiply by the square root of 3 is because the square root multiplied by itself is going to equal the radicand. So here you have a radical sign. Sometimes there's a number in this little position right here, and it's called the index. When there isn't a number in there, it means the square root. So for instance, the square root of 25 is 5. The square root of 5 times the square root of 5 is the square root of 25, which is equal to 5. Same thing with the square root of 3. The square root of 3 times the square root of 3 is equal to the square root of 9, which is 3, which is just the radicand. So 2 times the square root of 3 is what we have in the numerator, and in the denominator we have 3. 2 over 3 does not reduce, so our answer is 2 times the square root of 3 over 3. So that should bring back some memories. Refresh your memory of how to rationalize your denominator, simplify fractions as well. Here we've got the cubed root of 256 over 81. The cubed root means we're looking for groups of 3 things. So we've got the cubed root of 256 over the cubed root of 81. Now when you know your exponents, you know the cubed root of 256 is 4 times 4 times 4 times 4. It's 4 to the 4th power. And the cubed root of 81 is 3 to the 4th power. And we're looking for groups of 3. So we're going to be able to take a 4 to the outside in the numerator, and we're going to be able to take a 3 to the outside in the denominator. So we'll have 4 times the cubed root of 4 over 3 times the cubed root of 3. Now here in the denominator, I need to rationalize that. Well, to make it perfect, I would need to multiply by 2 more 3's so that I have another group of 3 3's. And I'm going to do the same thing in the numerator so that I'm multiplying by a factor of 1. In the numerator, I've got 4 on the outside, and I've got the cubed root of 4 times 9 on the inside of the radical. In the denominator, I have 3 on the outside, and then I've got the cubed root of 27, and the cubed root of 27 is 3. So I'm going to use a highlighter to show you, because this can be confusing. This cubed root of 3 times the cubed root of 9 gave me 3 3's, and because the index is 3, that was a perfect cube of 3. So our answer is 4 times the cubed root of 36 over 9. 4 and 9 are both on the outside. They don't reduce. So that's our final answer. Okay, now this next one is a good one for you to try. See if you can do this problem right here. Press pause and then come back and check your answer. However, when you come back and check your answer, I am going to explain this one as well, because it is a little tricky. You might have gotten it from the last example, but you might need just a little more explanation one more time before you can try these on your own in your homework. Okay, welcome back. I've got the 4th root of 32 over the 4th root of 27. Now, knowing my exponents, I know that this is 2 to the 5th power, so I know that this can become 2 times the 4th root of 2. I've got 5 2's in 32, and I need a group of 4 to make it perfect, so I bring one of them to the outside, but then I've got that 5th one that's left over, and that's what's on the inside. The 4th root of 27, well, on that one, I would need to multiply that. I need one more 3 on the inside, because remember, 27 is 3 3's. I need one more. So I've got the 4th root of 27. That's a 4 right there. And I'm going to multiply by the 4th root of 3. So what I multiply in the denominator, I need to multiply in the numerator. So then I'm multiplying by a factor of 1. And now we've got in the numerator 2 times the 4th root of 2 times 3 is 6 over the 4th root of 81, which is 3. So let me show you. The 4th root of 2 times the 4th root of 3 becomes the 4th root of 2 times 3. And in the denominator, the 4th root of 27, which is 3 cubed, times 3 is 3 to the 4th. So I'm just trying to show you one more way. Look at that. The 4th root of 3 to the 4th is 3. This right here, hopefully, if you don't have an aha moment right now, you will have an aha moment a little later on when we talk about rational exponents and radicals. But this is our final answer right here. 2 times the 4th root of 6 over 3.